Now, sometimes monopolists would like to engage in full or perfect price discrimination, but it's not possible for them because what it would require to accomplish it is illegal, or it would require information that they don't have. In such cases, they engage in more limited forms of price discrimination. And what I'm going to study with you in this video is a simple form of imperfect price discrimination. Let's call it a simple policy or price schedule, or a simple price schedule for imperfect price discrimination. And those schedules have the following form. They are characterized by three numbers: P1, P2, and Q bar. And the idea is like this. This is Q bar, this is quantity, and this is the marginal cost for consumer per unit. And the idea of this is that the consumer can buy as many as he wants at price P1 up to Q bar, and then any additional units are bought at a lower price P2. This is a simple class of price schedules that the producer could use, and if you think about them intuitively, they look like a quantity discount. After you have bought Q bar, I'd like you to buy how many you want at a cheaper price. Now, note, if price 1 equals to price 2, this looks like regular monopoly without price discrimination. So it nests the basic first model of monopoly that we studied without price discrimination as one special case. And we're going to assume two other things in the simple model. One is that the cost function is just constant returns to scale without fixed cost or semi-fixed cost. And the next thing is, just to make it simpler, is that there are C identical consumers, each with an inverse demand function given by PD of Q. This is going to be the demand function per consumer. As before, the solution to the problem is going to entail finding the best constraint price schedule that the monopolist can use to maximize his profits. But in order to characterize this, it's useful to start looking at the consumer problem. And in particular, I'm going to describe to you what the solution to the consumer problem looks like in 4 separate cases. In all of them, we're going to assume we're going to look at the same, exactly the same inverse demand function for a typical consumer. Okay, these are the same. And now let's ask, how does the solution changes? So in one particular case, maybe that the price schedule looks like this. It is, the kink is below the inverse demand function. In this particular case, the best that the consumer can do is pick this. Now, why is that the case? Well, think about it. Every unit up to here has a marginal cost of purchase, which is this, and then this, lower than the marginal benefit, which is given by the inverse demand function. So the consumer should keep producing all the way to here. Now, what if you have something that looks like this and never crosses? It should be obvious to you by now that the optimal is 0, because the marginal cost of purchasing exceeds the marginal benefit at any quantity. So these are the trivial cases. The more interesting cases are these two. Suppose that you have something like this that crosses the inverse demand function like this. Let me label these areas A, B, and C, and these quantities Q lower bar star and Q upper bar star. Then I claim that the consumer chooses Q lower bar star if this area B is greater or equal than C, and in contrast, it chooses Q upper bar star if the area B is less or equal than C. Let's see why. Now, what happens if the consumer jumps from this point to this point to this point? Well, the jump from this point to this point entails a loss, because every unit between here and here has a cost that is higher than the marginal benefit that it generates. However, if the consumer reaches this point and then keeps buying, let's say to reach that point, it can buy units, these many extra units from here to there at a marginal cost that are lower than the marginal benefit. So the key question is, what is the impact on the total benefit or surplus of the consumer from jumping from this point to this point? If the area B exceeds the area C, then that jump is not worth it and the consumer should stay there. If the area C exceeds the area B, the opposite is true. Now, the final case that is interesting is what happens if we have something like this? And let me call these areas B and C. Well, the case of interest here is this, Q star, and I claim that the solution here is 0 if the area B is greater or equal than Z, and Q star if the area C is greater or equal than B. And the reasons are identical, so I'm not going to repeat them. Now, given what we have just learned, it's easy to characterize the solution to the monopolist problem and the equilibrium allocation. So result with identical consumers, the monopolist gets all of the social surplus and the allocation is Pareto optimal. So let's see why that is the case. Look at the diagram of a typical consumer. It looks like this. Inverse demand function. We also have the marginal cost equals mu. We know that the Pareto optimal allocation, this is the amount that should be produced and given to that consumer or per consumer. Now, suppose that the producer, the monopolist, chooses a schedule that looks like this. Where this kink is at a Q bar equals to Q optimal divided by 2. Then, and the prices here is P1 equals PD of 0 and P2 equals mu. Let me call this A and B. Then, what do we know? We know that with this linear demand function, area A is equal to area B. We know that all of the producer surplus, all of the social surplus, which is equal to this triangle, goes to the producer. We know that the individual is indifferent between consuming 0 and consuming the optimal amount, so might as well consume the optimal amount. So we know that the allocation is also Pareto optimal. Now, notice the key intuition of the quantity discount here. I charge an excess amount to the consumers for the first Q optimal over 2 units, and he loses all of this, but he keeps buying because he can make that up by buying these extra units at a discount. And that's enough for me to know that he's going to end up choosing this march in equilibrium, the optimal amount, and to be able, as a monopolist, to extract all of the surplus. Now, important, result doesn't extend, this doesn't generally hold with heterogeneous consumers. And solving this problem in general is difficult, but the next practice problem is going to allow you to understand why, to get an important intuition in a simpler case.